Again, just one reminder, all the homework sets are reopened and they are due on April 27, Monday. So I think up until the second exam, there are still 3 homework that you haven't done yet, so make sure to check them. The last 3 are 4.4 and 5.5. And then the next one is 4.5. And then the last one is 5.1. So those are the 3 parts that we didn't cover before the second exam. I know most of you will probably wait until the weekend before April 27 to do the homework, but yeah, if you have free time, just go ahead and start earlier and finish them earlier. Any questions? Okay, so today I'm gonna finish up section 4.5. Section 4.5, we started on Wednesday. It's about substitution. So it's a way to reverse the chain rule. So last time we talked about U-substitution, and then I want to also tell you briefly how to pick the U function in general. So the function that you pick, in general, there would be the inner function. Can you guys hear me? Can you guys hear me?
Yes,
okay.
Can't see the video.
What did you say?
Yeah, I can't see the video.
Okay. All right, so yeah, so usually the way you pick U is I guess the first thing is U usually is the inner function. So usually U is an inner function, and by inner function I mean it's wrapped inside another function. So something like, I don't know, x squared plus 1, something good. Yeah, maybe x squared plus 1. So x squared plus 1 is inside the square root function. So one option is you pick U to be x squared plus 1. And then maybe something like 1 over 3x plus 4. So 3x plus 4 would be the choice because it's 1 over something. What else? So it could also be tangent of 1 over x. And this 1 over x would be your inner function because it's inside the tangent function. The second thing is, so this is something that's might not be obvious to you right now, but as you do more exercises, I'm sure this thing will be make sense. Okay, what do I want to say? Okay, and the second, yeah, the second thing, the second criterion is you pick U such that the derivative U prime shows up somewhere, I guess at least part of it. The derivative shows up, or part of it shows up in the integral. We'll do more examples, and then I'll tell you what I mean by that. But so far, any question? Okay, so let's do some examples. So I want to compute the integral of 7x times the square root of x minus 5. What do you think is what do you think I can pick my u function to be? Okay, x minus 5, because it's under the square root. So you pick u to be x minus 5, and so du dx equals 1. Eventually, I want to turn everything into u. So this is the same as saying du equals dx. And then I also know that from u equals x minus 5, I get x equals u plus 5. Does it make sense? Is it okay so far? Now, the next thing we need to do is to plug everything into this integral. How do I get du dx equals 1? Well, u equals x minus 1. So the derivative is 1. Now put everything in terms of u. So I know that x equals u plus 1 from here. So this is u plus 5. And I also know that, well, by definition, x minus 5 is u. So I get this is u. I also get that dx equals du. So change that into du. Questions? Cool. And you have 7 times u plus 5 times the square root of u, and you want to take the integral of that. What do I need to do? Okay, take the antiderivative. Do you mean I need to take the antiderivative of this and this separately? No. This is a product of two functions, and I say that when you take the integral of a product of two functions, if you're dealing with a product, if you're dealing with the integral of product of two functions, then you cannot find the integrals separately and then say that it's the product of the integrals, right? That's what we did before. So we cannot do that. What else can we do? I mean, you're going to find an antiderivative at some point, but before that, you need to multiply everything out. So I'm gonna put the 7 outside of the integral because it doesn't affect whatever that's inside. And then multiply the square root of u by u and 5. So I get u times square root of u plus 5 times root u. This equals 7 times the interval of u times square root of u. This is u to the 3/2. And for the second terms, 5 times root u. This is 5 times u to the 1/2. Is it okay? And now you take the antiderivative. So now you can take the antiderivatives separately. So the antiderivative of u to the 3/2, it's u to the 5/2 over 5/2. The antiderivative of u to the 1/2, it's u to the 3/2 over 3/2. And then don't forget plus c. Questions? Am I done yet? This? That's because, so root u is u to the 1/2, right? And so this is u to the first times u to the 1/2. So you get u to the 1 plus 1/2. 1 plus 1/2 is 3/2. Is it okay, Kristen? Am I done yet? So what is the last step? Okay, so the last step is you need to put in u equals x minus 5. Let's move on to the next page. So I get 7 times x minus 5 to the 5/2 over 5/2 plus 5 times x minus 5 to the 3/2 over 3/2. And don't forget plus c. Questions? Okay. Next example. So you have the integral of sine of x divided by 1 plus cosine of x squared. So what can I pick my u to be? Okay, so you can pick u to be 1 plus cosine of x. Is it okay for everyone? So does it make sense why I picked that? So there are actually many reasons that I picked that. One of them is it's inside a square function. Second reason is it's in the denominator. The third reason is what is a derivative of u? So what is a derivative of 1 plus cosine of x? the derivative of cosine of 1 plus cosine of x is negative sine of x, which shows up somewhere in the integral. Does it make sense? So that's what I mean by, so that's a point that I made earlier. Is it okay? And so you might be thinking that, what about 1 plus cosine of x squared? So why am I not using this? The reason is it just doesn't work. So this is just from experience. So if I pick that in the beginning, if I take the derivative and if I plug everything in terms of u, it wouldn't work. So I mean, the only thing I can say is you have to do a lot of exercises to see what's the best choice. But anyway, so I'm picking u equals 1 plus cosine of x here. And so the next step, I want to compute du dx. So what is du dx? Du dx, this is the derivative of 1 is 0, and the derivative of cosine is negative sine of x. And so du equals negative sine of x dx. Is it okay? Now, sine of x dx shows up in the integral. So multiply both sides by the negative. So negative du equals sine of x dx. That's something that I need to use later. So far, any questions? Okay, so the integral, so the original integral becomes the following. So sine of x times dx, I need to replace by negative du. So negative du. And then 1 plus cosine of x. This is u. So I have 1 over u squared. Is it okay? Now what do I do next? You take the antiderivative. So let's pull out the negative outside of the integral. So you have negative 1 over u squared. This is u to the negative second. And so what is the antiderivative of u to the negative second? What is the antiderivative of u to the negative second? No. That's a derivative. I'm asking, what is the antiderivative? Nope. Yep. So u to the negative second, the antiderivative should be u to the negative second plus 1 divided by negative 2 plus 1. And then you have another negative sign plus c. So if you simplify that, you're going to get u to the -1 plus c. What is the last step? You put u equals 1 plus cosine of x into your final answer. So this one should be 1 plus cosine of x to the -1 plus c. And that's it. Questions? So I have the integral of 1 minus root x divided by the square root of 1 plus the square root of x. What do you think I can take my u to be? Any ideas? So what do you think my...
Is that a square root over, like, of 1 plus the square root of x? Is that 2 square roots on the bottom?
Yep. So that's square root of 1 plus square root of x. And yes, you can pick this. No, you can pick this to be your u function. Again, one reason is it's inside the other square root. Second reason is it's 1 over, it's in the denominator. And again, the reason I'm not picking the square root of 1 plus square root of x to be my u function is because it's much more complicated. And you can try that, but it doesn't work. So I have u equals 1 plus root x, and let's compute du dx. So what is the derivative of 1 plus root x? Yeah, but there should be the 1/2 somewhere, right? Root x is x to the 1/2. So this one should be, the derivative should be 1/2 times x to the negative 1/2. Is it okay? And so du equals 1/2 times x to the negative 1/2 dx.
Shout out Chad. Thanks. Honestly, Chad deserves a fucking award because he was a lot to ruin my mood for a long period of time. And well, you did it, Chad.
I just want to make sure no random people show up in the meeting. Okay, so du equals 1/2 times x to the negative 1/2 dx. I want to put dx in terms of u, so you multiply by 2. I mean, you divide by 1/2 and then divide it by x to the negative 1/2. And so you get 2 times x to the 1/2 du. Is it okay? Questions? Questions? Is everyone following? How do I get the 2 again? So I want to move that to the other side. Matt. Matt, could you turn off the mic? Okay. It's okay. I mean, it would be funny if a teaching video has SpongeBob in. Anyway, so wait, does it answer your question, Christian? Okay, so dx equals 2 times x to the 1/2 times du. It would be better if I can put everything in terms of u, because that's what I'm aiming for. Because at the end, everything has to be in terms of u. So I need to put x to the 1/2 into a function in terms of u. That's when I need to go back to the original, to my definition here. So from u equals 1 plus root x, I know that root x equals u minus 1. Right? Is it okay? Now put this here. So x to the 1/2 is the same as root x. So I can turn that into u minus 1. Questions? And so the original integral turns into the following. So for the top, you have 1 minus root x, but I know that root x is u minus 1 here. So change that into u minus 1. I also know that 1 plus root x is u. That's by definition. So you have the square root of u. And then from our calculation, I know that dx equals 2 times u minus 1 du. So dx equals 2 times u minus 1 du. Questions? No? All right, what's the next step? Could you simplify the 2u minus 1? Yes, that's what I'm going to do that to do the next step. So before finding the antiderivative, you need to simplify the whole thing. Again, does everyone see that I cannot do the antiderivative right now? This is a product of two functions, and you also have a fraction inside the integral. So you need to simplify that before you find the antiderivatives. So yeah, for the top you have 1 minus u minus 1, and if you simplify that, you're going to get 2 minus u, and then multiply this to the top. So I get times 2 times u minus 1 divided by root u. Questions? Okay, so I'm going to pull the number 2 outside of the integral. And then I'm going to multiply this 2 together. How did I get 2 minus u? This is 1 minus u minus 1. So if you distribute the negative sign, you get 1 minus u plus 1. And so it's 2 minus u. Does that answer your question, Ryan? Okay. So 2 minus u times u minus 1. So I'm going to multiply the two orange together, 2 minus u and u minus 1. What do I get? So, wait, did I do something wrong? No. Okay, so just multiply everything. So you get 2 times u minus u squared, and then minus 2 plus u. And for the top, this is negative u squared plus 3u minus 2. Right? Right? Does it make sense? Any questions so far? No, how do I compute this? I want to compute the integral of negative u squared plus 3u minus 2 divided by root u. What do I need to do? Any ideas? Okay. Any ideas? I'm going to talk about two web examples after this. Okay, split the numerator. How do I do that? So root u, this is the same as root u to the 1/2. So we get negative u squared divided by u to the 1/2 plus 3u divided by u to the 1/2 minus 2 divided by u to the 1/2. And yeah, but I need to simplify this 3 first. So negative u squared divided by u to the 1/2, this is going to be negative u to the so what is the first term? So this is u to the no, you have square and you have 1/2. Three halves. So negative u to the 3/2. Second term, what is 3u divided by u to the 1/2? Yep, so 3 times u to the 1/2. The last term, minus 2 divided by u to the 1/2. What is it? Okay. So this is minus 2 times u to the negative 1/2. All right, and then take the antiderivative. I'll let you do that. And what is the last step after you take the antiderivative? You put in u equals whatever that was. I think u was 1 plus root x. So the last step is to plug that into your antiderivative. And don't forget plus c. Any questions? Okay. So before I talk about examples from the web work, I want to talk about U-substitution for definite integrals. So everything is going to be the same, except that you need to be careful with the lower limit and upper limit. I'm going to do just one example. So I'm going to do just this really simple example to show you how to do it. So I want to compute the definite integral of x minus 1 squared from 0 to 1. Is it going to be a number or is it going to be a function? It's going to be a number. So the only difference is you need to compute the antiderivative. You need to compute the integral, the antiderivatives, and then the last step is to put in 0 and 1. So I guess the first option you can do is you can compute the indefinite integral first, and then plug in 0 and 1 at the end. So to compute the integral of x minus 1 squared, you can either use the U-sub or you can find an antiderivative right away. Or if you don't like this, if you want to compute indefinite integral, then you can compute that right away as follow. So again, what do you think my u function should be? Yep. So what do you think my u function should be? X minus 1. So u equals x minus 1, du dx equals 1. And so du equals dx. So the definite integral can be written as follows. So if you want to turn everything in terms of u, you also need to change the lower and upper limits. So when x equals 0, so the lower limit when x equals 0, what is my u? Using u equals x minus 1, when x equals 0, what is u? -1. And when x equals 1, so this is the upper limit. The upper limit is x equals 1, and the corresponding u value is, well, you need to plug you need to plug 1 into this. So 1 minus 1 is 0. So if you turn everything in terms of u, the lower limit is -1, the upper limit is 0. And then x minus 1 squared is u squared, and then dx is du. Make sense? And then you can compute the antiderivative of u squared. What is the antiderivative of u squared? It's going to be u cubed divided by 3. And because I'm computing definite integrals, because I'm computing the definite integral, I need to put in 0 and -1. Does it make sense? So this is 0 minus -1 cubed divided by 3, which is just 1/3. Questions? No questions? Cool. Let's look at this example on the webwork. So this is question 3 in my webwork. You want to compute cosine to the 15 of 7t times sine of 7t. So what do you think my u function should be? Okay, let's try that. So u equals 7t, du dt equals 7, du dt equals 7, so du equals 7 times dt. And so your integral becomes cosine of u, sine of u, and then dt is du divided by 7. Does this seem like something you can do? Hello? Why? So do we have a formula for the antiderivative of cosine to the 15 times sine of u? No. Then what does it mean? Okay, you need to pick a new u function. So I'm not saying that this is wrong. You can actually do this, and then you can actually do the u method again. But to make things simple, I can start with a slightly more complicated function in the beginning. So what do you think my u should be? What do you think a good u function can be? So we said in the beginning that the u you're going to pick is going to be inside another function. That's one option. The second option is it's such that the derivative shows up somewhere in the integral. And you have cosine and sine, right? What do I do? Okay, so the problem. Okay, so I'd say that they are two. two ways to pick the u function. One is it's inside another function. Second is the derivative shows up in the integral. And I know that the derivative of sine of 7t shows up in the integral somewhere, but a better choice is actually cosine of 7t. And that's because it's inside the power function, because you have the 15 here. Does it make sense? And yeah. So du dt equals negative sine of 7t times 7. So du equals negative 7 times sine of 7t dt. So this is what I mean. This thing right here, it looks exactly the same as the sine of 7t times dt. And so I'm going to divide everything by negative 7. So you get du divided by negative 7 equals sine of 7t dt. Is it okay? And so your integral becomes by definition, u was cosine of 7t. So the first thing is u to the 15. Sine of 7t times dt. We know that this is du divided by negative 7. Is it okay? Now, does this seem like something you can do? Okay, I'm not getting much response today, but I'll let you figure out how to do this, how to continue this. I'll let you figure out if this is the correct way or not. But before you go, I need to take the attendance. All right.